Okay, so we'll do these more detailed next class, but I do want to kind of point out, again, we've got to watch our restraints every time. They can change. So this would be going to 2 pi back to negative 2 pi. So you definitely would have to look at that plus or minus period adjustment. And again, this is happening to the x, so that means it is going to change my period. So you have to take that into consideration first, or using that plus 2 pi k and deal with the algebra as you go. In terms of looking at what I've got over here, notice that this is negative root 2 over 2. So you're thinking when is cosine equal to that, or when is the x coordinate equal to root 2 over 2 and then negative. So you think again to the when is cosine negative, and then when is it equal root 2 over 2. So this is going to be our pi over 4s. And again over here with a half, you're asking, because this is all inside the parentheses, when is cosine a half? That's just your unit circle question. And then you're going to do your phase shift algebra at the end. This one won't have a period adjustment, but we'll look at those next class. So I want to move to example 2, and I'll probably look at both of these because notice that in particular they have things inside the cosine function but also outside the cosine function. So this has a couple of things outside the cosine function. So again, I'm only looking for answers between 0 and 2 pi. And this time it includes those, so that's a big deal. But because this one isn't in the cosine function, I actually have to move it first. So anything outside of cosine, anything being added or subtracted outside or multiplied in front, you have to do the algebra first before you answer the question, when is that cosine equal to that? So I'd have to subtract 1, then I'd have cosine of 2x equals negative 1. And then, okay, so now when is cosine equal to negative 1? And that is actually one of our axes values. Remember, it's not a half or root 3 over 2 or root 2 over 2. So in this case, cosine is negative 1 right here because those coordinates are negative 1, 0 on the unit circle, and cosine is your x-coordinate. So that happens at pi. So this cosine equals negative 1 at pi. I know that it repeats every 2 pi after that, so 2 pi k, so it equals it at pi. But then if I want another 2 pi, it would be 3 pi. Another 2 pi would be at 5 pi. So this keeps happening every 2 pi k. And then I actually now am going to solve for what's inside of here, which is that's when cosine of x equals negative 1. I want to know when cosine of 2x equals negative 1. So now I'm going to solve algebraically. These don't have any fractions in them, so I'm actually going to go ahead and divide by 2. I divide everything by 2. So now I know my answer is at pi over 2. That's the first time it happens, plus I divide this out. I get every pi again it will happen. And that is a period compression, so you're going to have more answers. So if I have an answer of pi over 2, and I have to add pi to that, basically, again, if I want to play the same game I showed you in the beginning, I'm going to turn this into 2 pi over 2. And I want to end at 4 pi over 2, because that is equal to 2 pi. So if I add 2 pi over 2 to this, I would get another answer. That would be 3 pi over 2. That is within my boundary. If I added another 2 pi over 2, I'd have 5 pi over 2. That's too big. And if I subtracted 2 pi over 2, I would be negative. So this has 2 answers in the boundary that I gave you. So again, the reason I want to show these is I'm doing some algebra before and some algebra after. So that's kind of the part that's a little bit different. It is really, if you think about it, similar to if I had x minus 2 squared, and if I put like a 5 out here and a minus 1 out here, and I said equals 0, you got to add the 1 first, then you're going to divide by the 5, and before I can add this 2 to solve it, I would have to get rid of this square by taking a square root. So this step right here is getting rid of the cosine before I divide by the 2. So it is similar, it just looks a little bit different because there's a word there instead of a square. All right, so this, again, this is the part I need to get all by itself, is the cosine portion of it, in the same restriction that I had before. So the first thing I'll do is subtract 1 from both sides, and I'll just kind of show you all of the steps. Then I have to divide by root 2, which is not a big deal. except that when I do that over here, that equals 1. So I have cosine in the parentheses x minus 3 pi over 4, and it equals negative 1 over root 2. And so this is not something we're used to seeing on the unit circle. And remember, this would be on paper 1 without a calculator, so you'd be expected to know what this equals. So that means it really has to be on the unit circle. Otherwise, it would be on paper 2, and we would use our calculators like last class, which means this I need to rewrite it so that I recognize it, which is getting rid of the radical on the bottom. So if I rationalize that by doing root 2 times root 2 on top and bottom, I get a negative root 2 on top and 2 on the bottom. And that is now going to be helpful because that is what I talked about a minute ago. Again, this is inside, so I'm just first asking when is cosine negative root 2 over 2? And again, all students take calculus. Cosine is positive in the first and fourth quadrant, so the answers to this have to live in quadrant 2 and 3. And it's root 2 over 2 is always the pi over 4s. So that's 1 pi over 4, 2 pi over 4. So one of my answers is 3 pi over 4. That is 4 pi over 4. And so the other answer is 5 pi over 4. So those are my two answers before I take into account that I have a phase shift. So I now put what's in the parentheses on the left, and I have my algebra afterwards to solve. Again, these answers are going to repeat every 2 pi. So I could put in a plus 2 pi k here. And that period isn't going to be changed by adding this. I'm going to add it like terms, so I'm going to add it to this. I don't have to worry about adjusting the period, but it's not bad to have it in front of us. I'm running out a little bit out of room, but that's all right. I can make adjustments. So I'm going to add 3 pi over 4 to both sides. Boom. Plus 3 pi over 4. That's gone. I'm going to rewrite this answer down here. I'm going to bring it down. 3 pi over 4 plus 3 pi over 4 is 6 pi over 4 plus 2 pi k. I'm going to deal with that in a minute. And I do the same thing down here. Plus 3 pi over 4 is going to cancel. Plus 3 pi over 4. This answer I'll write right below it. 3 pi over 4, 5 pi over 4 plus 3 pi over 4 is 8 pi over 4 plus 2 pi k. And so I can do a couple of different things here. You can simplify first. These are both going to simplify to the same denominator. So this would be 3 pi over 2 plus 2 pi k. This would be 2 pi plus 2 pi k. And actually, this aren't over the same denominator. I don't know why I said that. 2 pi plus 2 pi k, remembering that I'm captured between 0 and 2 pi. So my answers have to be between 0 and 2 pi inclusive. So if I add 2 pi to this, if I were to get a common denominator for this side, that would be over 2, and that would make this a 4. And this would be the same as 4 pi over 2. That's equal to 2 pi. So one answer is 3 pi over 2 right here. If I add 2 pi to that, I get 7 pi over 2. Way too big. If I subtract 4 pi over 2, I'm negative. So this is the only answer I get for my first portion of it. I also get an answer of 2 pi, which is cool because I know that I include 2 pi. If I add 2 pi, I'm way too big. But if I subtract a 2 pi, I'm back to 0, and I'm allowed to include that this time. So these would be my 3 answers for that problem. And again, thinking about the IB exam, you get points for method and approach. So, you forget to do this period adjustment, you're just not going to get all the points for your answers, but you should get some points for the process and method along the way. All right, we will practice these next, and they take a little bit of practice. So it's brand new. It's okay. That might be a little bit much. We're going to take it step by step and keep looking at them.